So my name is John Snow, and yeah, I know. I'm a software engineer for Red Hat. I've been working on the incremental backups. My would-be co-presenter, Vladimir Sementsov-Ogievskiy, couldn't be here today, unfortunately, so I'll be covering his portion towards the end. So before I begin, just a couple of acknowledgements. So this feature kind of has been through the washing machine for a few cycles, and it was initially proposed by Jigane Sundar in 2011, and his work kind of informed some of the directions we've gone since then, so I wanted to put him on the slide. The feature as it exists today came from Fem Zheng's patches a year or so ago. And I'd like to thank Stefan and Max for mostly the reviews and the patience. So for an overview, talk about what the problem is, the approach, the design goals. Then I'd like to discuss some of the building blocks for the feature before getting to the life cycle and example of how to use the feature to accomplish incremental backups. And then towards the end, I would like to discuss some of the advanced features which Vladimir has been working on, which is the migration, the persistence, and some of the interface for the functionality. And at the end, some project status, questions, and answers. Okay. So the problem. If you make a first backup, and it's 128 gigs, and you need to keep making backups throughout the week, and it's 128 gigs again, and again, and again, and again, regardless of how much data has changed on the disk, it's kind of gross. There's a terrible storage efficiency here. It's clunky, it's slow, but it is somewhat simple and convenient, so it might be the preferred solution for people as it stands now, because it's very easy to roll back to a particular day. Not a lot of complexity. So what we'd like to do is, even though we still have to make a full backup for the first day of the week, for instance, it would be nice if subsequently we can just copy out just the data that has changed. Much better. Only copies the modified data, and it's fast. We're only copying out just a little bit, so you can copy more data. But maybe it's more complicated. I would like to convince you that that's not the case. So the approach, as mentioned, this came from or was inspired by Jigane Sundar's live backup in 2011. He gave a talk on it at the KVM forum back then. His approach used separate CLI tools to manage the backup data. So there was a server and a client that you had to run to copy the data out of Qemu. It used an entirely new network protocol for the feature. It ran as an independent thread outside of the existing Qemu infrastructure, so there were some concerns perhaps about the data safety. It used temporary snapshots to manage the atomicity of the feature, and it was implemented with in-memory dirty block bitmaps. It was ultimately not merged after he moved on to other projects. So in 2014, I think, is when Vam started working on his version, and it is also a dirty sector bitmap-based solution. We're using the HBitmap and bdrive dirty bitmap primitives that already existed in Qemu. We didn't create any new external tooling or protocols. It's managed via the existing QMP interface. We implemented this as just a new backup mode, so there's not a plethora of new commands or management burden here. We can use it with any image format. It's not tied to a particular format, though some are nicer to use than others. And we are hoping that this maximizes the compatibility with existing backup tools, infrastructure, frameworks, so on. So design goals. We wanted to reuse as much as humanly possible, as mentioned, to hopefully streamline this into existing customer solutions. So we already have the block driver dirty bitmap. It was already tracking dirty sectors for us for drive mirroring and migration. It already had a configurable granularity, and we can attach as many of these as we need to per drive. So by using these, it doesn't interfere with, for instance, mirroring or migration, anything like that. We are reusing the drive backup command, which is implemented via QMP. It can already create full backups or point-in-time live backups. We can already export data via an existing protocol, NBD. We don't have to invent any new tooling or protocols there. All we have to do is add a new incremental sync mode and maybe a bitmap name argument so that we can instruct the backup framework to know what data to copy. So for coherency as a design goal, we wanted to be able to do multi-drive point-in-time backup across multiple drives. We wanted to use the QMP transaction feature to accomplish this instead of cooking up a new complicated solution. We want this feature to be persistent, so the bitmaps have to survive shutdowns and reboots. And again, we didn't want this to depend on any particular data format or the target data format, so we wanted this to remain a flexible solution. It needs to be migration safe. So migrating must not lose or reset bitmap data because that would make it not super useful. Cloud usage, of course, we want to be able to shuffle these machines around. So migration needs to remain working for us. For error handling, we don't want to lose any of the data on backup failure, which I know sounds obvious, but a design goal here is that if a incremental backup fails, say you run out of storage or there's some kind of protocol error, we lose the ability to create the backup as we would in that point of time, but you can just start a new incremental immediately afterwards and you can get an incremental from that point in time. If a backup fails, you don't have to start all the way back with a new full backup. And for the integrity, we want to make sure that we can at least detect any desync between the persistence data and the bitmap as it exists. We don't want to be copying any incremental backups out that are garbage. So this was going to come up sooner or later. It's come up a few times on lists. People ask, why don't you use snapshots? We already have point-in-time functionality that people are using to roll back to specific points in time. And they look, well, why not use that? We can use the feature as described to free ourselves from a lot of format dependency. So we don't care what format the data is in or where it's going. We don't care what format the snapshots are. So this gives us a lot of flexibility in that sense. Moreover, the incremental backups that are created, they're inert. They don't change on disk. There's no, they're not live. They're not hooked into anything. So we can create as many incrementals as we want. We can delete them. There's no overhead of shuffling snapshots around. So this is a little nicer for us and for management utilities, hopefully. And again, we can use the existing frameworks for backups, and hopefully extending management utilities like libvirt won't be too difficult for us. So I will get on to talking about the primitives. So the block dirty bitmaps, it was an existing block layer structure that we're using to track writes for migration and drive mirroring. It's implemented using a hierarchical bitmap, which was already there for us to use. Any number can be attached to a drive, which is useful if you want to have multiple backup schedules for the same data. So you can attach as many bitmaps as needed, and you can use those bitmaps to accomplish different kinds of backup schedules as appropriate. It should be a flexible solution. So the block dirty bitmaps have names. The existing internal usages are anonymous, so you can't address them with commands. They're basically transparent to the user, but any bitmaps created for incremental backups will have names. The name is unique to the drive, but it's not a global ID. So the node name pair is the ID you will use to address commands to the bitmap. So the bitmaps, as mentioned, have a granularity. So by default, they are tracking writes at roughly 64 kilobyte increments. You can make it smaller and hopefully you will save yourself some size on the incremental backup, but it depends on the usage pattern. So you'll use more memory in exchange for hopefully smaller backups, or you can increase the granularity to maybe have larger bitmaps with less memory usage. But the default is 64 kilobytes, and you don't have to specify one. It's completely optional, but it will attempt to match the cluster size of the file format you're using, which for QCOW2 is 64K. So more or less, the default is 64K, but it can change. So the bitmaps track writes per sector, but you specify the granularity in bytes. So if you specify a granularity of about 64K, you'll get a granularity of about 128 sectors. So any write to any 1 byte on your disk is going to cause you to have a backup immediately of 128 sectors there. But the backup engine itself is also copying out per cluster, and its notion of a cluster is also 64K. But then you also have to remember that the file format itself has a cluster size. So depending on the tuning for these 3 levels, you may find yourself wasting more space than you expected. For instance, right now, because we're copying out in 64K increments, if you set it to any lower than that, you're not going to see any space saved regardless, so you have to be aware of the tuning. So for now, probably stick to the default, and we can work on tuning this in future versions if needed. So for the management of these things, it's managed via QMP, which is really good news if you're a computer, because you already know how to talk that protocol. There are 4 commands. Add, remove, and clear there were added for this feature, but query block already existed, and I will get to explaining why that's there. So to create, and I should mention before I go too deep down the rabbit hole here, all of these examples are already in the documentation tree, so if anybody goes, oh, that's neat, I want to implement a backup program for this, all the examples should work as is without modification, so you can go run and copy-paste those and make prototypes to your heart content. So creation. They can be created at any time on any node. They begin recording immediately. There's no mess, no fuss. The granularity is optional as stated. Here we used one for 128K because smaller, as mentioned, is still a bad idea. Deletion. We can delete them at any time. They don't affect any of the backups we've already created. They don't affect other bitmaps attached to the node. The only thing you can't do is delete it while you are making a backup, but hopefully you expected that. We can also clear or reset a bitmap. It's mostly for convenience, but it does begin recording new writes immediately, just like add. You don't have to reactivate it or anything like that. For querying, there is the existing query block command, which returns an awful lot of stuff. I've trimmed out the bits that aren't relevant to our interest right now. Here, this shows an excerpt for a device named drive 0. And you can see the bitmap 0 down there, and there is status active, which means that it is currently on and recording writes, just in case you didn't believe me when I said it is recording writes as soon as you add it. It can show frozen there as a string, which means that it is currently in use for a backup, and that's when you can't delete it. So management utilities can check to see if it will succeed or not before it tries to issue the command. Hey. And here, the count is the number of sectors. It'll depend on the sector size of the block device, but for 512 bytes and a granularity of 64K, this is going to be about 2,000 clusters or so. So you can kind of predict somewhat the size of the backup before you issue it by using the query block command. However, QMP commands, as you may be thinking already, are not super useful by themselves. They're not atomic. We can't issue across multiple drives. They're only really safe when the VM is offline, so that's kind of useless. And we can't get any kind of multi-drive coherency guarantee with that. So we have transactions. Bitmap management transactions will let us do all kinds of stuff. We can create new full backups while adding or clearing bitmaps. We can reset, clear, create new sync points across multiple drives. We can issue incrementals across multiple drives. So this gives us the data safety that everybody was, maybe worried about before we got to this slide. For supported actions, we have add and clear. Nobody cares about remove because we're getting rid of it anyway. It will work in conjunction with the drive backup command, which also has a transaction that's already in Qemu. And this will let us do incrementals, full backups, new chains, and sync points, and so on. So with all that gobbledygook out of the way, I can show an example of the life cycle for how to manage some of this. Woo. So generally, you'll create a new bitmap. You'll attach it to a drive. You will create kind of a synchronization point between the bitmap and the backup. And then from there, you can create as many incrementals as you want. And then if in the future you want to create a new sync point, you can roll back or just keep making incrementals. So for example, this is how we'd create a new chain. You can use the add and drive backup commands there, along with sync full down there, to create a full backup and clear the bitmap at the same time, so you can be assured that any new writes that come forward will be tracked for your next incremental. So you start with something like this, really boring. It's just a box, but we can attach a bitmap and create a full backup somewhere on disk, perhaps, and count 0 because there's no dirty writes now. Or say we have an existing bitmap and you just want to reset it. Say you were testing something or it's Sunday and I got to start a new backup chain. You would use the clear and drive backup commands in tandem, and again, sync full for the full backup. So you'd start with something like this, where we have a bunch of dirty sectors, but for whatever reason, we decided we wanted to start a completely new backup. So now the full QCOW2 backup is old. We don't need it. You can delete it if you want, but we've successfully, in one transaction, created a new backup chain. So, first incremental, the interesting stuff. I know I've been promising that it's format independent, but QCOW2 is really super useful. It has backing files, and we like those. So you can, for instance, create, with Qemu image on the command line, a new empty QCOW2 file with a backing file of the old full backup. And then you can issue a drive backup command using sync incremental, which is highlighted down there. You can use the single QMP command, which I have illustrated here, or like I said in the README already in the docs folder, there's examples of transactions, which you can issue a bunch of drive backups across as many drives as you would need to. So for an example again, here we've got a bitmap that's accumulated some dirty sectors to it, and when we issue the command, poof, the bitmap's cleaned out, and now we have a new incremental that is much smaller than the full backup, but thanks to the backing file, you can just point directly to the new incremental file, and it's a complete point-in-time snapshot there. So subsequent backups. For any there's nothing special you need to do. It's basically the same command as last time. You just point to the last incremental you made. And you can continue forever until your hard drive is completely full and you are sad inside. Advanced features. These are the ones Vladimir was working on. Lots of good stuff. So bitmap migration. The mechanism is similar to the live disk migration in that we split it into chunks and then we send it piece by piece. And while the guest is still writing, we can catch that and copy extra pieces as we need to. The chunks are a little bit smaller. We do 1 kilobyte, hopefully to fit in an Ethernet frame. But if all of your bitmaps together are below 1 meg, we skip the live phase and we just copy the data in one chunk. For an example of kind of how much sizes you can expect there, a 64 gig disk with the standard sector size and the standard granularity for the bitmap, you're only using 128K for the bitmap, so it's not too big. Though, of course, it does have to spend a couple of bytes transferring the names and stuff, but not a big deal. They're very small. So the bitmaps are not transferred alongside data. You don't have to migrate the block to migrate the bitmaps. So you can, with or without the data, migrate the bitmaps over, whatever's more convenient for your solution. We manage, I had to put this in here because it was funny when we were reviewing it, but we manage the live the live migration of the bitmap data with bitmaps that track the bitmaps. Thank goodness, they're called meta bitmaps now instead of, yes, dirty bitmaps. It was It's not too good. And that uses very, very little memory, so hopefully those don't, make anybody's day too bad. We do have to still discuss how this is going to interoperate with persistence. So if you save a bitmap to disk and then you want to migrate with or without the disks, we have to figure out what our policy is going to be for where we're going to stick this bitmap during migration, because there's a lot of different routes it can take. But for now, we do have patches on list awaiting review, and hopefully we'll be able to get that in for 2.5. So persistence. Persistence is the good one that everybody's curious about. We can save bitmaps across shutdowns because without that, that would be kind of not much of a solution at all. It's a work in progress right now. We're targeting a QCOW2 extension for saving the bitmaps. We are going to be using it hopefully as a generic container, which is modeled kind of after how snapshots are stored. But we don't require that you use QCOW2 for the data, for the backups, for the drive. We just want to use it almost like a zip or a tar file for containing our bitmap data. So we can store them in an empty QCOW2. You can store multiple bitmaps. If you have 100 drives, you can store all of those in the same thing. It doesn't matter. But for convenience, of course, we can store a bitmap alongside the data it does describe and have it auto-load when you pass that into Qemu. So if that doesn't sound good for you, you should go on the list and tell us why. But it was chosen because we didn't want to implement a brand new file type and complicate the command line. So we reused, again, existing infrastructure to kind of manage bits of data. Yeah.
Proof creation of new VMs with data inside. So you could just copy your core image with your VM, and you will have all the data which has been already collected.
So to-dos, we still need to decide on a QMP interface for modifying the persistence attributes, because we haven't quite yet decided how we're going to store the persistence, so we haven't gone too far on that yet, but we will need to be able to choose and decide which bitmap gets stored where, or if we want to change it, turn on persistence for a bitmap, turn off, we still need to create a couple of CLI tools for verification, analysis, and managing the bitmaps inside so we don't get junk data that we carry around forever. We still need to add in support for checking the validity and repairing it, maybe in Qemu image check, I don't know. We still need to discuss the data integrity, the data integrity of the persistence. So we have not yet implemented like a periodic or opportunistic flushing back to disk. So at the moment, it's only on load and on save. So we need to work on that just a little bit. And as Dennis Lunev suggested, we may convert the migration over to using a Postcopy solution where we just migrate the names and some of the metadata over, and then we can worry about copying the bitmaps over after we've already migrated, because merging two bitmaps is trivial. So we can just put the bitmap into, for instance, kind of like a semi-frozen state where it's marked as inconsistent until all the data has arrived. But merging that into Postcopy is something that we are looking at doing. So, last bit. So, project status. The block dirty bitmap QMP interface, already in. The sync incremental mode, also already in. Transactions, 2.5. The migration is on list. I expect that to go in shortly. And the persistence is still in RFC for now. And so hopefully 2.5 or maybe 2.6. And that's it. Any questions?
Is there any litmus or sort of high-level tooling support there?
Not yet. I'm hoping that... Actually, I should repeat the question for the thing. I was asked if there's any libvirt tooling support. So not yet. My hope is that by not straying far from how backups are done already, that it won't be too hard to add in. But of course, the libvirt people would have more opinions on that than I would.
So if you can do the backup across multiple drives at the same time?
Yeah, so the question is if you can do incremental backups across multiple drives at the same time. Yeah, just use the transaction. You can add bitmaps to all the drives in advance. And then if you want to create coherent backups across as many as you want, you can add as many commands to the transaction as you want. So you can do multi-drive backup. You'll just have one drive backup action per drive. And I don't think there's a limit to how many you can issue. So if you want 100 drives and you want them all to have a backup at the same instant, you can do that.
One question. When you're doing that incremental backup,
Yes.
After you run that command, I guess it's asynchronous, right? After that's done and it's being flipped from frozen to active again,
Yes.
do you emit some kind of event or something?
So the question is if there is some kind of an event that's emitted after the bitmap is flipped from frozen back to active after an incremental backup, and not a discrete event at the moment. You'll get the standard backup completed event, and it happens with that. If there's a use case for an additional event, we can add one. I suppose I should take the second to mention that if the backup fails as well, and you don't get the backup, the block job completed event, the bitmap will roll back from frozen to active, but it will merge any writes that occurred during that window back into the bitmap, so you won't lose any of that data in the interim. Nope. Okay, I think we're good then. Thank you. Just a quick shout out to, if you have any questions, if the design of some of the later features you would like to comment or contribute to, please send me a mail and CC the mailing list so that we can make sure that this feature is as good as possible. Thank you.